This is section 6.3, polynomial functions. A lot of what we're going to do today is an extension from section 6.1. In section 6.1, we were simplifying monomials, we were simplifying polynomials. We are going to do that same thing today with polynomial functions. In the past, I've given you something that looked like this. F of x equals 2x minus 5, and I asked you to find f of, say, negative 2. How would you do that? Plug it in. You put negative 2 in for x, wouldn't you? Use your calculator to find the answer. That's what we're going to do today. The difference with what we're doing today is, and what we've done in the past, is that's not always going to be a number. That might be a monomial, it might have a variable, it might be a binomial, some kind of expression. So we're not just limited to doing this with numbers. We're also going to do this with functions. Okay. So before we get to evaluating those functions, I want to talk about something called polynomial and one variable. So on the top of your notes page that you have, it says to state the degree and leading coefficient. If it's not a polynomial and one variable, explain why. Okay, so there's kind of two tiers here. We talked earlier in this chapter about a polynomial. There were two things that made an expression not a polynomial. Do you remember what those two things were?
Under the square root and denominator.
That's correct. If a variable appears under a square root or a variable appears in the denominator of a fraction, we do not have a polynomial. Okay, so that's kind of tier 1. Tier 2, it's asking you to extend this thinking. It's asking, is this a polynomial in one variable? All that means is that we simply have one variable throughout the problem. We only have z's, right? So that is considered a polynomial in one variable. Look at example number B on your handout. Letter B there on your handout is not a polynomial in one variable, is it? Because it has a's and b's. So if it is a polynomial in one variable, I want you to identify the degree and the leading coefficient. Okay. So obviously this is a polynomial. Yes, it's a polynomial in one variable. I'm going to say yes for both of those. What is the degree of this polynomial?
3.
The degree is 3. Remember, we take the highest power. And I'm going to use LC for leading coefficient. A coefficient is the number in front of a variable. When I say leading coefficient, I am stating, if I was to put this expression in order from highest power to lowest power, what term would come first? This one would come first, wouldn't it? The 7z cubed, because it's the highest power. What's the coefficient on that leading term, that first term? 7. Okay. They may give you an expression that's mixed up, maybe not in the right order. So in example B, we said this was not a polynomial in one variable, correct? Because it has more than one variable. But is it a polynomial? It's a polynomial, isn't it? It's not in one variable. If I ask you for the degree, what would you tell me the degree is for letter B? The degree would be 3. Okay. So I'm going to say that no, it's not a polynomial in one variable, but I can give the degree. It's 3. Don't worry about the leading coefficient here. I'm not concerned when it's not a polynomial in one variable. Letter C, is this a polynomial?
Yes.
Absolutely. I don't have a variable in the denominator, nor a variable under the square root. So definitely a polynomial. Is it a polynomial in one variable?
Yes.
Yes, I simply have x's throughout and no other variable. What is the degree of this polynomial? The degree is 6. What is the leading coefficient? Before you answer, it's the term, if I was to put this in order, it's the term that's going to come first, coefficient. Negative 8. Okay. If I was to put this in order, wouldn't negative 8x to the 6th power come first? So negative 8 is my leading coefficient. I'm going to use LC for leading coefficient. Letter D, is this a polynomial?
Yes.
Absolutely it is. Is it a polynomial in one variable?
Yes.
Yes. have x's, so it is a polynomial in one variable. What is the degree of this polynomial? And the leading coefficient is also 3. Letter B. Okay. We'll do E, this will be our last one here. Is this one a polynomial on letter E?
No. Oh,
It is a polynomial, right? Is it a polynomial in one variable?
No.
It's not, because
It has one.
it has 2 different variables. So if they ask you to explain why, you would simply say there's 2 variables. Or you could say that term 2xy makes it not a polynomial in one variable. If I ask you for the degree, I think you could give it to me. What's the degree?
2.
The degree would be 2. Okay. I'm going to skip down to the back side. Skip problems 2 and 3 for right now. Go to the back side. On the back side, we are evaluating some functions. This is what I told you the bulk of our lesson today is on. So it says to find g of negative 5 if g of x is equal to x squared minus 5x plus 8. When it says g of negative 5, that simply means use the g function, right? The g function that's given. What are we going to put in for x? Negative 5. So let's calculate g of negative 5. Don't try to overthink this. Let's just use our calculator to evaluate this function. So on the calculator, let's type it. We have parentheses, negative 5 squared minus 5 times negative 5 plus 8. Did you get 58 also? So when I put negative 5 in this function, I get out 58. There's really not going to be a whole lot of work to show when you're just evaluating a number. Now, when we put an expression in, it might be a different story. Might have to do a little bit more work. Look at this next example. I want you to find g of 5a. So this time, we are still using the g function because it says g of 5a. So we're using the g function. And in place of our x's, both x's, I'm putting 5a. So g of 5a. Now we have to remember our exponent rules, and we have to remember how to simplify polynomials moving forward. In that first term, I have the quantity of 5a squared. We know our exponent rules tell us to square everything inside, correct? So 5 squared is 25, and a squared is just a squared. Negative 5 times 5a is negative 25a plus 8. Do we have any like terms that we could further combine? No, this is our answer. In this example, it says to find g of 5a minus 2 if g of x equals x squared minus 5x plus 8. So this g here tells us to just use the g function. And in place of our x's this time, I'm going to put a binomial in. So for both of those x's, let's replace them with 5a minus 2. So think back to how we simplify polynomials. If we have a binomial squared, like we do here, what did we do to simplify that? Very good, we have to FOIL that. So what I'm going to do is just ignore the rest of the problem for just a minute, and I'm just going to focus here on FOILing. 5a minus 2 times 5a minus 2. Let's FOIL that out. We have 25a squared minus 10a minus minus 10a plus 4. We should be able to FOIL, I think. Now I've got some like terms there in the middle. I'm going to go ahead and combine negative 10a and negative 10a. So 25a squared minus 20a plus 4. Is that my answer? No, that's just a small part of my problem, isn't it? Let's incorporate the rest of this problem in. I do need to distribute my negative 5, but I'm going to do that next. I'll just carry it down with what I've got in my problem so far. So negative 5 times 5a is negative 25a. And negative 5 times negative 2 is a positive 10. And then plus 8. In our next step, I think we've got a few like terms that we can combine. So I'll start here with my 25a squared. I don't have any other a squareds, so I'll bring it down. I've got negative 20a and negative 25a, which is negative 45a. And the remaining terms are constants that I can add. 4 plus 10 is 14. 14 plus 8 is 22. Let's look at this one next. So in this example, we're on number 7. We have b of 2x minus 1. We're finding if b of m is equal to 2a squared plus m minus 1. Again, this is number 7 on the back side. So the b here tells me to use the b function. And in place of these m's, I'm going to put 2x minus 1. Alright, so we need to determine, should I FOIL this binomial squared, or should I go ahead and distribute the 2? If you think about PEMDAS, what should you do? Don't we want to do our exponent before our multiplication? But exponent is telling me I'm going to have to FOIL. Okay, so I do need to take care of this first, and then I'll distribute the 2. So let's just take our 2x minus 1 times itself, and we'll FOIL that out. So we've got 4x squared minus 2x minus 2x plus 1, which is going to become 4x squared minus 4x plus 1. What do I need to do to that 4x squared minus 4x plus 1? Distribute the 2, that's right. So I've got this 2 here. You have to take that I FOILed and take it times 2, which is going to give me 8x squared minus 8x plus 2. From here, let's bring down the rest of our problem. I'm going to bring down the 2x minus 1. There's really nothing to do to that, so just plus 2x minus 1. And I have minus 1. So let's combine our like terms. I don't have any other x squared, so I'll bring down 8x squared. I do have negative 8x and positive 2x. Negative 8 plus 2 is negative 6x. And if I add my constants, 2 minus 1 is 1. 1 minus 1 is 0. So we have 8x squared minus 6x. I'd like to change one of these problems. Yes.
So on the last one, I kept it in parentheses and I distributed
The previous problem?
No, on
This one? Mhm.
But on the last thing in parentheses, I distributed to -1. So
This one
how
here?
how do I know when to get rid of the parentheses?
Good question. This would be a -1. You're just subtracting one. I didn't distribute anything because there's nothing in front here.
Okay.
If there's a number in front, you'll know to distribute.
Alright.
Good question. Let's look at number 8, but I want to change that problem. Instead of doing 2a or 2x plus 1, let's just do 2x. So we're going to find g of 2x.
Okay.
And I actually want to change two more. Let's do 3g of 2x. What do you think we might do with that 3? Yeah, after we put the 2x into our function, I want you to multiply everything by 3. When that 3 is next to this, it just simply means multiply. Now, we are first going to calculate this, all right? Let's find g of 2x first, and then we'll take our answer times 3. So g of 2x. So in place of these b's, or this b, I'm going to put 2x. 2x squared plus 3. Using your exponent rules here, I've got 2 squared, which is 4, and x squared plus 3. Of course, these aren't like terms, so I can't add them together. According to my problem, I'm asking you to now multiply by 3. So let's take this expression and multiply by 3. I'm going to multiply each of those terms by 3. So 3 times 4x squared is 12x squared, and 3 times 3 is 9. So 12x squared plus 9. I'd like to go back and look at the problems that we skipped a second ago. On the front side, numbers 2 and 3, so if you guys would just go back over. Starting with number 2 there, it says respiration. The volume of air in the lungs during a 5-second respiratory cycle can be modeled by the given function, where V is the volume in liters and T is the time in seconds. This model is an example of a polynomial function. Find the volume of air in the lungs 1.5 seconds into the respiratory cycle. This is a whole lot of words for evaluate the function. They're giving us this function right here. And they're asking us to find the volume. Volume is V. That's been in the lung, the air that's been in the lungs for 1.5 seconds. Where would be your best guess of putting 1.5? In for T. Don't do anything fancy, just use your calculator to evaluate this. So let's practice typing this in, because sometimes this can be tricky. We type this in, we have negative 0.037. Number 2. Negative 0.037, parentheses, we're putting in 1.5 into our function, cubed, plus 0.152 times 1.5 squared plus 0.173 times 1.5. When we type in all these decimals, it's easy to forget a number. Type it in incorrectly. I mean, I just typed it in accidentally incorrectly. So make sure that as you're typing it in, you're double checking before you hit enter and just assume your answer here. I think I got it in correctly. Did you get 0.476625? No? If you didn't, let me know. I can help you figure out where you went. So let's round this. I'm going to say it's about 0.48. 0.48 what? What are we finding? Finding the volume. What is our volume being measured in? What unit? Volume in liters. So this is just shy of a half a liter. Look at the next one with me. The height of a toy rocket during a 2.35 second flight is predicted by the function that's given, where h is the height in meters and t is the time in seconds. This model is an example of a polynomial function. Find the height of the toy rocket 1.25 seconds into the flight. They're giving us this function and they're asking us to use it to find the height, h, of the toy rocket 1.25 seconds into the flight. Where am I going to put 1.25? In for t. Let's put it in for t. Let's go back to our calculator and calculate this value. So -4, parentheses, we have 1.25 to the third power plus 6 times 1.25 squared plus 8 times 1.25. Again, double check that you got it typed in. You didn't make a silly mistake in your calculation. I have 11.5625. So according to my answers that were given, 11.6 meters would be the best. We're looking for the height, so it's the height is being measured in meters. That's where my label came from. 11.6 would be fine. 11.6 meters. So today we are evaluating polynomial functions. We may have to evaluate just a given number. We might have a monomial, might have a binomial. Use your polynomial, your rules of polynomials. To simplify. Today's assignment is out of your textbook. Before I give you the assignment, tomorrow we have a quiz scheduled over section 6.2 and 6.3. 6.3 is what we did today. Section 6.2 is on dividing polynomials. So that's like the long division, synthetic division, and also polynomial divided by a monomial. If anybody's worried about the division portion of your quiz, come in during advice, I'll give you some practice problems, and we can work together to make sure you're on the right track. That's not a problem. Today's assignment is right here, we're on page 352.